Dear students, in the present class, we shall discuss about some chemical properties of carboxylic acids. Chemical properties of carboxylic acids. Here we need to discuss about four important chemical reactions. One is reactions involving cleavage of OH bond. It is, if you consider the general formula of the carboxylic acid. This is the general formula of the carboxylic acids. The first type of reaction is reactions involving cleavage of OH bond. Here, this is we have to discuss. Reactions involving cleavage of OH bond in carboxylic acids. That proves the acidity of the carboxylic acids. Then the second type of the reaction is reactions involving cleavage of CO bond. Okay, CO bond. Where not this CO bond. Here we need to discuss about the chemical reactions involving cleavage of this C and this O bond. This breakage of this bond is little bit difficult because double bond is a stronger bond when compared to the single bond. Okay. Then the third type of the reaction is reactions involving cleavage of reactions involving COOH group. Means reactions due to all this group. Reactions due to all that carboxyl group. Okay. The fourth type is substitution reactions in hydrocarbon part. This substitution reactions in hydrocarbon part or alkyl or aryl part. Okay. So about these four types of the reactions, our discussion starts with the first one. Okay. Yes. What is the first one? Reactions involving cleavage of OH bond. Okay. And I already told you that it proves the acidity. It proves the acidity of carboxylic acid. It proves the acidity of carboxylic acid. So we know proton donor is an acid. Proton donor is an acid. According to which concept? According to the Bronsted-Lowry concept. Okay. According to Bronsted-Lowry concept, proton donor is an acid. Here, let us visualize some of the reaction equations. There, the carboxylic acid is donating a proton that leads to the acidic character. Okay, this compound has that acidic character. That is why the compounds are called as carboxylic acids. Okay, the name is itself acids. Yes, definitely the properties of acid will be exhibited by this compound. Means it turns blue litmus to red. Okay, this will sour in taste, etc. Okay. Yes, let us consider some of the reactions now. The beauty of the carboxylic acids is it will react with a metal and releases the hydrogen gas. Okay, reaction of the carboxylic acid with reaction of carboxylic acid. I will just write the C for carboxylic acid. Reaction of carboxylic acids with active metals. Like sodium. Okay, I am going to give you a general reaction equation. This is the carboxylic acid. This is the carboxylic acid. It is treated with sodium metal. Okay. So what happens? This is a active metal immediately reacts with this and replaces the hydrogen. To become a sodium salt of carboxylic acid. Sodium salt of carboxylic acid. How many hydrogens are coming? One hydrogen. That must be represented in a molecular form. That must be represented in a molecular form. And this upward arrow mark indicates this is a gas. Okay, hydrogen gas. Okay, the formation of or evolution of the hydrogen gas proves the acidity of the carboxylic acid. Okay. Similarly, the alcohols also react with the sodium metal, produces hydrogen gas. Phenol also react, okay, and produces the hydrogen gas. Similarly, the carboxylic acid also. Okay. Go for the next one. Reaction of carboxylic acids. Reaction of carboxylic acids with the base. With the base. Like KOH, NaOH. Okay. Like that. Let's take down this RCOOH reacts with NaOH. Okay, and use that RCOONA. Then what will be the byproduct here? ONA is H plus ion will come out, joins with OH minus ion and produces H2O. That is what. This is an acid, that is why reacting with a base. When acid combines with a base, the product will be salt and water. Okay. Yes. Come to the next one. The carboxylic acid even reacts with a weak base. NaOH is a strong base. Okay. Carboxylic acid even reacts with a weak base like sodium bicarbonate. Okay, or it is also called as a baking soda, and it also reacts with the sodium carbonate. Okay, reaction of carboxylic acids even with the weak bases, Okay, come to that. Take the RCOOH. Okay, this is the carboxylic acid plus NaHCO3. This has variety names. In one where that is commercial name is baking soda. Then another name is sodium hydrogen carbonate. Another name is sodium bicarbonate. Okay. When this acid react with this weak base, we get RCOONA. That is sodium salt of carboxylic acid. It is a salt because it will be carrying negative charge and it will be carrying the positive charge. Here also negative charge, positive charge. Negative charge, positive charge will be there. It is a salt. Okay. And what are the byproducts? This H will combine with OH of this and becomes H2O, and remaining is carbon dioxide. See, you are getting the carbon dioxide. Whenever you treat the carboxylic acid with baking soda, you can see the brisk effervescence of carbon dioxide. This is a test used to detect the presence of carboxylic acid. Whenever the carbon dioxide is coming, it gives a brisk effervescence. When that CO2 is passed through the lime water, the lime water turns turbidity. We can detect the presence of carboxylic acid by lime water test. Okay, we can detect the presence of carboxylic acids by lime water test. Okay, yes. Then, if carboxylic acid is treated with a sodium carbonate, RCOOH is treated with a sodium carbonate. This is called as sodium carbonate. Sodium bicarbonate is different, sodium carbonate is different. What happens here? There are sodium atoms. No? Here there are two sodium ions, so that requires 2 moles of the carboxylic acids. Okay, it will give 2 moles of RCOONA salt. The remaining is H2O. Okay, the remaining, how many H2O will come out? Here you have 2 hydrogens, so therefore you will get 1 mole of H2O, and the carbon dioxide is there. Okay, 1 mole of carbon dioxide will come out. Okay, in both the cases we can see the brisk effervescence of CO2. Okay, generally we use this one. Okay, the detection of carboxylic acids can be done with a lime water test, that is by using a baking soda or sodium carbonate. This is one method of detection, and another method is esterification. The next one is conducting the litmus test. When the blue litmus paper is subjected for the carboxylic acid, it will turn to red. Okay, so these are all the detection of the carboxylic acids. Okay, here you can take the detection of carboxylic acids. Detection of carboxylic acid. This is an extra. This is an extra point. Okay. One is litmus test. Second one is esterification. Okay. The third one is lime water test. Yes, this is about the detection of the carboxylic acid. Come to this. Here we are discussing about the acidity of carboxylic acid. To prove the acidity, carboxylic acid, when treated with the sodium metal, gives hydrogen gas. Okay. Then, when carboxylic acid is treated with an alkali like sodium hydroxide or potassium hydroxide, it will give a salt and water. When carboxylic acid, it even reacts with a weak bases, okay, and produces carbon dioxide and water. These reactions proves the acidity of carboxylic acid. Here you can see the cleavage of OH bond. Here OH bond is broken down, and this O is joined with the sodium ion. Here also you can see the cleavage of this OH bond. O is joined with the sodium ion. Again here also. Means what I mean to tell you is the cleavage of OH bond proves the acidity. When this bond is cleaved, that H plus ion comes out. So it is like carboxylic acid is donating a proton. Proton donor is called as an acid. Okay. Yes, here we have to discuss about the comparison of acidity of these carboxylic acids with the mineral acids and the phenols, alcohols, etc. Here we are going to discuss about the comparison of acidity between the carboxylic acids, mineral acids, phenols and alcohols. Regarding the acidity of alcohols and phenols, already discussed in the previous chapter. Here, let's consider these carboxylic acids and mineral acids. Mineral acids are always strong acids. What are the mineral acids? Like HCl, H2SO4, nitric acid. These are all called as mineral acids. These are strong acids than the carboxylic acids. Okay, consider the order of acidity. Okay, mineral acids are strong acids than the carboxylic acids. Than the carboxylic acids. Okay. The acidity will be measured in terms of pKa values. Will be measured in terms of pKa values. The pKa value for this will be, okay, pKa value for this will be, pKa values will be around less than 0, for this, less than 0. Okay. Yes. What are the examples from mineral acids? For example, you may take HCl, H2SO4, HNO3, whose pKa value will be less than 0. Okay. Then come to the carboxylic acids. These are acids out of all the organic compounds. Okay. Whose pKa value ranges from 1 to 5 or 1 to 10. Don't know, it is dependent on the compound we are going to take. It will be greater than 0. We can say greater than 0, and it will be from 0, okay, to 10. We will take approximately 0 to 10. We will take. Okay. Then carboxylic acids are stronger acids when compared to the phenols. Let us also discuss about the reason why carboxylic acids are stronger acids than the phenol. I will tell you that. Okay. Here phenols whose pKa value will be around 10. Okay. Will be around 10 to 15. You may take. Okay. 10 to 15. And the phenols are acidic than water. Water is more acidic than the alcohol. For this alcohol, pKa value will be more than 15. And etc. Okay, and etc. See here, what you are observing, when pKa value is less, then it will be a strong acid. Here, you need to remember this order of acidity. Mineral acids are stronger than the carboxylic acids. These are stronger than the phenols. Phenols are stronger than water, and water is more acidic than the alcohol. I will tell you why. Okay. Here, before going to know the reason for that, let us consider the equilibrium or dissociation constant of the carboxylic acid. Let us discuss about dissociation constant. Dissociation constant Ka of carboxylic acids. Dissociation constant of carboxylic acids in water. Okay. Take the carboxylic acid RCOH and take the water. This is nothing but hydrolysis of carboxylic acid, you can say. Okay. This is Ka. Here it is an acid, no? Than water. You can see that carboxylic acids are acids than the water. It donates a proton. It will lose the proton to the oxygen. So it will become a carboxylic ion. RCO minus. Okay. What is this? This is a carboxylic acid. Okay. Here it is acting as a base. What is the function of a base? It is a proton acceptor. Okay. Here, what is this? Carboxylic ion. Now, this is called as a conjugate base of this acid. This is called as a conjugate base. It is a base because of the presence of the negative charge. It is a base, and here it is the conjugate base of this acid. What are conjugate acids and bases? These are differ by a proton. Here proton is there, here proton is not there. That is why it is called as a conjugate acid base pair. Okay, and here after taking that hydrogen from this carboxylic acid, this will be H3O plus. Okay, we call this as hydronium ion. Hydronium ion. Okay, and this is a conjugate acid of this base. This is not required, but in order to show you how this acidity is related with the pKa value, we need to understand what is Ka. Ka is what? Dissociation constant of an acid here. Okay, now when you calculate dissociation constant Ka, we take the product of concentration of the products, RCO minus, multiplied with concentration of the hydronium ion, H3O plus, divided by product of concentration of reactants, concentration of the RCOOH and concentration of the water. Okay, for pure solvents, the concentration is equal to unity. The concentration is equal to unity. Okay, here see that if this is more, usually the acid, carboxylic acid, more acidic than this water. Water here it is acting as a base. Therefore, it is readily donating the proton and becoming carboxylate ion. Means here numerical value increases. Okay, the value of the numerator increases. Okay, here as the if more and more number of acids are becoming ions, okay, this value will be more, then Ka will be more. Okay, means acidity will be more. Acidity is directly proportional to the Ka. Okay, and it is inversely proportional to the pKa because pKa is negative logarithm of Ka. pKa is negative logarithm of Ka, or you can also take 1 divided by log Ka. That is pKa is inversely proportional to Ka. Okay. If the dissociation of the acid is more, then it is a strong acid. Okay. If Ka is more, then acidity will be more and its pKa value will be very less. This is very important point. That you can understand from here. We told that mineral acids are strong acids because whose pKa value is less and whose dissociation constant will be more. Means these are readily donating the H plus ions than the carboxylic acids. Carboxylic acids are readily donating the H plus ion than the phenols. Okay. Now we shall discuss about the acidity of the carboxylic acid versus the phenol. Okay, we shall discuss about the acidity of. Let us consider the carboxylic acid, and it can undergo dissociation to give carboxylate ion plus H plus ion. Okay, similarly consider the dissociation of phenol. It will give phenoxide ion. Okay, carboxylic acid will give carboxylate ion. Carboxylate ion. Phenol will give phenoxide ion. See here, the carboxylate ion is more stable, while phenoxide ion is less stable when compared to this. Okay. Why? Here, this negative charge is balanced with conjugation. Okay. Here, the negative charge is also balanced with the conjugation. But this resonance is involving the negative charge is present on the oxygen atom only. Okay. But here, the negative charge is present on the oxygen as well as on the carbon atoms. Okay, as well as on the carbon atoms. That is why here this fails to maintain the negative charge. Okay, that is why it is a little bit unstable, and if it requires some time to donate a proton, and this carboxylic acid doesn't require much time to donate a proton, it immediately donates a proton and becomes a carboxylate ion with a more stability. Okay, here carboxylate ion is more stable. That is why carboxylic acid is more acidic. Okay, here I am going to give you the conclusion that carboxylic acids are more acidic than phenols because of greater stability of carboxylate ion than phenoxide ion respectively. Okay, here the carboxylic acids are more acidic than the phenols because of greater stability of carboxylate ion than the phenoxide ion. Here, if the carboxylic acid loses a proton, then also it will be stable. Okay, but here it is not so stable when compared to the carboxyl. It is stable, that is why it is donating a proton immediately. Okay, so this is all about the acidity of carboxylic acids and phenols particularly. When you consider the alkoxide ion, it is unstable. Alkoxide ions are unstable. That is why it is least acidic. Okay, that also you can take here. Note, alkoxide ions are unstable. Therefore, alcohol is least acidic. Okay. Here you need to observe the acidity of carboxylic acid is dependent on the stability of carboxylic ion. Acidity of phenol is dependent on the stability of phenoxide ion, and similarly the acidity of alcohol is based on the stability of the alkoxide ion. You can take one more time that order of acidity. So carboxylic acids, okay, carboxylic acids are stronger than the phenols. Phenols are stronger than the alcohols. Okay, and here order of stability you take. If the ion is having greater stability, then it will be a greater acidic. Okay, carboxylate ion is more stable than the phenoxide ion. Okay, and phenoxide ion is more stable than the alkoxide ion. Okay, here what you are going to observe, greater the stability, greater will be the acidity. Greater the stability of the ion, greater will be the acidity of these compounds. Okay, so this is all about the comparison of acidity of carboxylic acids, phenols and alcohols. Then we shall go for the factors affecting acidity of carboxylic acids. Let us discuss about the factors affecting acidity of carboxylic acids. Here there are two factors. One is electron withdrawing groups and another one is electron donating groups. These are going to affect the acidity of the carboxylic acids. Yes, let us see that. Firstly, let us consider effect of electron withdrawing groups. Electron withdrawing groups. Say the electron withdrawing groups. Let us see that with the structure. It is the carboxylate ion. No? If R is electron withdrawing group, okay, then it will withdraw electrons from the carboxylate ion. Okay, then it will withdraw electrons from the carboxylate ion, and here the negative charge will be easily stabilized. The negative charge will be easily stabilized with the help of this electron withdrawing group. Okay, consider the oxygen is carrying the negative charge. It is the burden on the oxygen. It is burden on the oxygen to maintain the negative charge. And now that burden is again shared with the electron withdrawing group, whose function is to withdraw electrons, to take electrons. So the burden on the oxygen is reduced now. Now it feels happy, it feels stabilized. So it will be readily donating a proton to becoming a negatively charged ion. Therefore acidity will be increased. Okay. So electron withdrawing groups, stabilizes the carboxylate ion, stabilizes the carboxylate ion, thereby increases the acidity, thereby increases the acidity. Acidity due to electronic effects. Electronic effects means here it may be inductive effect or it may be resonance effect. Okay, due to electronic effects. Okay. So what is the topic? The effect of electron withdrawing groups. These are stabilizing the carboxylate ion and thereby increasing the acidity of carboxylic acids due to the electronic effects. Let us consider some examples. Okay. Let us consider some examples later. Okay. Go for the next one. What is the next factor? Electron donating group. Electron donating groups. Okay. Now consider the carboxylate ion structure. Okay. If the R is electron donating group, it is releasing the electrons to the carboxylate ion. Imagine you are carrying some 50 kgs on your head. You are carrying 50 kgs on your head. If someone is coming and putting more burden on you, okay, more kgs on you, what you feel? You feel more burden. You will become unstable. You cannot withstand that weight, okay, and you will collapse. That happens. Okay. Here also, already the carboxylate ion is having trouble with the negative charge, or the carboxylate ion is bearing the or uh, holding the negative charge. Okay, that is somehow trying to balance the negative charge due to resonance effect. And here comes a person or a group, that is alkyl or any other group, that is electron donating group, and it is donating electrons towards carboxylate ion and increasing the negative charge on the carboxylate ion, and it is putting more burden on the group. It will become unstable. That is why it won't want to become, it don't want to become a carboxylate ion. It will be carboxylic acid only. It don't want to lose the proton and face this critical situation. Okay, that is why the electron donating group destabilizes, the electron donating group destabilizes the carboxylate ion. The electron donating group destabilizes the carboxylate ion, thereby decreases the acidity. Thereby decreases the acidity. And the reason is also same, electronic effect, due to electronic effect. Due to electronic effect. Okay. Let us consider some examples. In case of acetic acid, okay, take CH3COOH, okay, replace one hydrogen with a fluorine. Replace one hydrogen with a fluorine. What is this fluorine? It is an electron withdrawing group. Fluorine is electron withdrawing group. What it will do? It increases the acidity. Okay. Now the acidity of this is more than this because of presence of electron withdrawing group. That electron withdrawing group shares the negative charge, shares the burden on the carboxylate ion, becomes more stable. Okay. Then replace one more hydrogen of this. Here one electron withdrawing group is there, here two electron withdrawing groups are there. So as the number of electron withdrawing groups increases, stability of carboxylate ion increases, acidity also increases. Okay, finally, CF3COOH. It is the most acidic carboxylic acid. It is the most acidic carboxylic acid. In the entire carboxylic acids, this trifluoroacetic acid is the most acidic one due to presence of 3 electron withdrawing fluorines. Okay. As the number of electron withdrawing groups increases, acidity increases. Okay. Yes. Here, electron withdrawing groups are directly proportional to the acidity. Electron withdrawing groups are directly proportional to the acidity. Okay. Consider one more. You have CF3COOH. You have CCl3COOH. You have CBr3COOH. Which one is most electronegative? The fluorine, which is electronegative than the fluorine, which is electronegative than the bromine. Then which will be more acidic? This one. electron withdrawing tendency or electronegativity increases, acidity will be increases. Okay. Yes. Let us consider some other examples. This is a benzoic acid. Take methoxybenzoic acid. Methoxy is the electron donating group. It donates electrons to the benzene ring. So you know that electron donating groups decreases the acidity. Okay. Take the benzoic acid again. Take the nitrobenzoic acid. What is the function of nitro? It is electron withdrawing group. Okay, it is electron withdrawing group. Out of all this, the methoxybenzoic acid will be the least acidic. Will be least acidic than the benzoic acid, because here benzoic acid is common, no? This is in between, neither carrying electron donating nor electron withdrawing. Okay, it is at the middle now. Electron donating methoxy group decreases the acidity. Okay, and electron withdrawing nitro group increases the acidity. So therefore, methoxybenzoic acid will be having a less acidity, and it will be benzoic acid will be more acidic than this, and nitrobenzoic acid will be more acidic than this benzoic acid. This is the order of acidity. This is all about order of acidities. Okay, you need to remember only two things. Electron withdrawing groups increases the acidity of carboxylic acid. That is why directly proportional. Okay. Electron donating groups decreases the acidity. That is why it is inversely proportional. That is why it is inversely proportional. Electron withdrawing groups increases the acidity. Electron donating groups decreases the acidity. Okay. This is all about the acidity of carboxylic acid. In addition to these two, you need to remember the acidity is directly proportional to dissociation constant Ka and inversely proportional to the pKa. These are all very, very important, and more number of questions have been appeared in JEE, NEET, KCET, even in theory examinations. That is why you need to practice a lot on these topics. Okay, thank you.